In this video, I explain about the proof of binomial distribution. Mu r plus 1 prime is equal to np mu r prime plus pq d over dp, means derivative with respect to p, mu r prime. So now let's start. By definition of earth moment about origin, mu r prime is equal to expected value of x per r. When we expand expectation, we write it as sum of xr, x power r, p of x. P of x is the probability mass function. It is also called probability density function, also called for binomial distribution. P of x is equal to ncx px q per n minus x, and the random variable x range from 0, 1 to so on n. So we apply this PDF and random variable in this equation. Random variable x start from 0 to n, x per r. Write the formula for p of x ncx p per x q per n minus x, and differentiate it with respect to p. Differentiate with respect to p. Mu r prime d over dp is equal to d over dp sum of x ranges from 0 to n, x per r, ncx p per x q per n minus x. xr ncx, we apply the derivative to p of x and q per n minus x. Because these are constant terms, in these two terms there is no involvement of p. Because we differentiate it with respect to p, so the term other than p assumed to be constant, and we take constant outside the derivative. So using the product rule, we write q as 1 minus p, because q plus p is equal to 1 and q is equal to 1 minus p. So we can use here 1 minus p per n minus x. So take the derivative, because these two terms are multiplying with each other. So we use product rule of the derivatives to solve this. What is product rule? I write here product rule. If you have two numbers u and v, we suppose that any two numbers u and v, so we take derivative with respect to x. So first term write as it is, take the derivative of second term, plus first term as it second term as it is, take the derivative of first term. So now we apply this in this equation. Here x ranges from 0 to n, x per r and cx, these are the constant term outside, and the bracket start. First write first term as it is, p of x, and take the derivative of second term, which is 1 minus p per n minus x, plus write the second term as it is, which is 1 minus p n minus x, and take the derivative of first term, d over dp p per x. So now we solve this using power rule, which is when you have power and take derivative, we decrease power by 1 and multiply with the number with power. So here n minus x is the power we use when power rule. Multiply n minus x with this number 1 minus p and decrease power by 1, n minus x minus 1, and take the again derivative d over dp 1 minus p, plus so 1 minus p per n minus x, and apply power rule here, x p power x minus 1, x per r ncx p per x, 1 minus p per n minus x, and 1 minus p power minus 1, n minus x. And when you take again derivative of 1 minus p, it is minus 1. Power derivative of 1 is 0, derivative of 1 is 0, and derivative of p is minus 1, plus 1 minus p per n minus x, (1 minus p power n minus x) and x, and we solve this p of x. Now again p of x 1 minus p power n minus x 1 minus p power minus 1 n minus x power minus 1 plus 1 minus p power n minus x p power x n dot x p power minus 1. So sum of x is equal to 0 to n x power r n c x p c x 1 minus p power n minus x. Here in this equation take the common of p of x 1 minus p power n minus x. From this equation take the common of p power x 1 minus p power n minus x. These two terms take common. We left here with n minus x over 1 minus p. Because of this minus we write this term on this side because it is the minus term and this term is plus term. So when take px 1 minus p power n minus x common, we left here x over p. X over p is the plus term, so we write here x over p minus n minus x over 1 minus p. So taking the LCM p into 1 minus p, cancel out p with p, we left x multiply 1 minus p. Here is a sign of minus, n minus x, cut 1 minus p with 1 minus p, and here we left with p. So multiply x minus xp minus np minus minus plus xp. Cancel out these two terms, minus xp and plus xp. So we left with x minus np over pq xr, and here we left with ncx p power x 1 minus p power n minus x. So the p of x, here is the formula of p of x. So x is equal to 0 to n x power r p of x x minus np over p of x by cross multiplication. Take this pq term on the right side, pq d over dp mu r prime is equal to x ranges from 0 to n x power r plus 1. When multiply this term, this is 1 and this power is r, here we write it as x power r plus 1 p of x minus np, x ranges from 0 to n x power r p of x. pq d over dp mu r prime is equal to expected value of x r plus 1. Here we can write it as expected value of x r plus 1 minus np, expected value of x power r. X ranges from 0 to n x power r p of x. We write it as expected value of x power r, expected value of x power r plus 1. So expected value of x r plus 1 is equal to mu prime r plus 1. Expected value of x r is equal to mu r prime. So we write it as pq d over dp mu r prime is equal to mu prime r plus 1 minus np mu r prime. So mu r plus 1 prime is equal to npq np mu r prime plus pq d over dp mu r prime. So hence we prove the equation. If you want to see videos about mean and variance of binomial distribution, then click the link in front of your screen. Please subscribe my channel Statisticians Club, and you can find all the proof of discrete and uniform discrete and continuous distribution on my channel Statisticians Club. Thanks for watching.